Hey guys, looking at 4F. First thing we've got is a beautiful mountain and a view down to a person standing on the ground. We're going to be making that into the view to the very top, so we do have a right angle in our beautiful triangle there. Now, he is 28 degrees of elevation first, so we're putting that one in. We then move 140 meters closer to the mountain, so making that triangle a little bit further in, and then it is 43 degrees. Our question here, once we get our beautiful line in, lots of beautiful lines today, I'm not sure why, they just are. Not very straight though, are they? Rulers are your friend, please use them in your workbooks. 43 degrees. So we've got a couple pieces of information, we've got some angles, we've got one of the sides, and we want to know the other side. Specifically, that new direction from the top of the mountain down to where Harrison has now moved, which is that second line that we drew. Get that on there. Okay, so we've got our x, which we're trying to find. We've got a bunch of angles, we know where the 140 is, but we don't really have, like 43 degrees isn't part of our actual triangle that we're now using, which is that obtuse triangle with the 28 degrees in it. The 43, however, is on a straight line with the other side of that, so we can work out that side by 180 minus the 43. It's 137 degrees in that beautiful little section there. How many beautifuls this morning? Not sure where they're coming from. We can, of course, now use our sine rule as we've got our two angles and two sides. Of course, the angle we needed for the 140 is the one up that top end. So again, interior angles with triangle 180. Take the other two parts away to get our angle up there. 15. So our 15 is opposite our 140 side, and our 28 is opposite our x. Chuck them into our sine rule. Let's grab our sausages, our aeroplanes, our band-aids, whatever we're calling them today. 128 with x and 140 with 15. And we should hopefully by now know what this one's looking like. It is on the formula sheet, so don't freak out too much. We then just have to solve for x. And in order to do that, when we've got fractions like this, we are just going to cross multiply just that one side, so that x is going to be the 140 times the sine 28 over sine 15. And chucking him into a calculator will get us to our final answer. We did want to go to the nearest meter from memory, so we are going then to 54. Next one, captain of ship A sighted the smoke of a volcanic island, direction of north 53 east. Guess what? A compass is going to be our friend anytime you've got bearings, whether they are compass bearings or true bearings. A compass is your friend. Draw it, work out where it is. Gives you a bunch of parallel lines. We love parallel lines. Also shows you like your quadrants and things to give you where your 90 degrees are, which is very useful at various points. So our N53E we should know is going to be in here. We've got ship A down in the center of that compass. We've got a second ship that is 30 kilometers due east of the first ship. So along that east line we're going to have this second ship coming. He's going to have his own north, because we need him to have the compass bearing of north 42 west, which is back the other direction, and our 42 in between that line and our north. We want to know how far ship A is from the volcano and how far ship B is from the volcano, to one decimal place for each of them. So we're going to chuck our 30 kilometers on there, work out some angles so that we can find the other side. Now, each bit there we've got a couple of right angles, so we should be having our 90 minus our 53 to get the interior angle, our 90 minus our 42 to get the interior angle, and then of course our 118 minus our other answers to get that top angle that we need. So we have all three angles of the triangle, and we can do pretty much whatever we want from there. Just a sec to get all of those answers. And 180 If you're still getting stuck on your interior angles and where your complementary and supplementary angles are, you need to really kind of pay attention to when it says you've got your north, your east, etc., because you're going to have lots of right angles and they will make your life a lot easier finding stuff. Our top angle there is 95. Now, side angles, trying to find another side, that is the sine rule. 95 is across from the 30, that's why we needed that 95. We can just use the other two angles. Our A side, so we've got, oh, yeah, did these backwards. So my X here is actually going to find ship B's length. The pink side was ship B. Yep, I was paying attention when I did this. And then our Y side will be finding ship A, so the purple length on the left hand side. And for each one we are using that 30 over sine 95. So X is the answer for B and Y is the answer for A. I need to grab a couple quick answers here, and we are going correct one decimal place for each of these, but I'll just put on the basics. You guys can work out your decimals. Hopefully by now we're okay with their decimals. Alright, so it'd be 18.1, and our next one would be 22.4. Make sure you are rounding those decimals properly. Now we want to know the closest ship, which is of course our ship B is much closer, and our time is of course in that same fraction we were using before, which is speed is distance over time, so time is distance over speed, moving our equation around to get t as the subject, chucking our distance, which was 18, over our time, which was 20. It gives us 0.9. We need that 9 degrees, minutes, seconds, which you guys can just click on your calculator. Unfortunately, my calculator doesn't have that button because I'm writing it all. Is, however, 54 minutes. To the nearest minute. Ta-da!